Okay, welcome to Coffee Compiler Club. We spent 5 minutes prior to recording talking about the future of modular versus NVIDIA versus the rest of the AI marketplace. But we're here generally to talk about compilers. Doesn't have to be AI compilers or modular. Everyone's being recorded. We'll all show up on YouTube in an hour or two or 10 or something. Done the spiel. Um, and out of the project for this morning, this afternoon, is to sort out my long history of talks, public talks, and figure out which ones to give to what audience and what order at Modular. Um, and I went back through the list. It's actually, I should throw it into the Docker chat here. Wonder if I can do that. Crap, it's on the Apple, which is on a KV switch. I have to flop it from Apple to Windows through the KVM switch, which is not convenient. Because some of them would make sense for people who watch this channel to be interested in and see. There's a lot of interesting history there. No, 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 that's not what I want to do. I want to do this. I want to do this. I want to, no, where's the other one? Yes. Bam. Okay, here is docs. So somebody say something about something while I screw around with docs for like 5 minutes while I figure out how to cut and paste between hardware things that are not
I was going
connected
to say that
physically.
finding your name on a list of speakers was how I found my way here in the first place a couple of years ago.
Well, there you
And
go.
and but I don't think I ever found a
Oh,
proper
crap.
list
Figures.
of docs. Would have been nice to be able to do that. I think
Black.
I found one or two, and then they turned out to be quite similar to each other. So yeah, it'd be great to have like a list of like which ones you recommend people
Okay.
watch.
Emacs.
Uh, because yeah, I mean, the only way to find out if they're worth watching is basically to watch the whole thing. Anyway,
So from what I watch um, on Cliff's talks, the things are he talks are more high level because he doesn't want to get into too much compiler details. And yeah.
yeah. Well, one of the talks that I thought that I liked the best for me early on was one where it was a little bit awkward because the audience was not a compiler audience at all, and people
Mm,
didn't seem to know anything about compilers
mm,
at this conference. So he went right, started defining terms and stuff that didn't
mm.
typically find, and I found it very useful.
Yeah. An interesting moment for me was when he talks about the unzipping thing, and it sounds so abstract, but once I get it what it means, so yeah, it means the unzipping thing. But
Yeah,
after you get what what he generally means about that.
yeah, for sure.
Ah, okay. Some cut and paste magic through Dropbox got me back. So the KV switch, by the way, kills the sound because, of course, it's coming through the PC's connection.
Okay, so
See, links is not a great way. I'm gonna slap this bad boy here, and then we'll figure out what we're gonna do with links here. So these are not links; these are just an unsorted list of talks. Um, and one per line. What if I can pause? What did you do? Oh, come on. Oh, Google. Wow, there's a docs API being stupid. Never mind. Here, how about this? Oh, that looks a little better.
Hmm.
Okay, so fine. So there's, in theory, a pile of talks. Um,
yeah, I was just
you
saying
you
that.
were talking and I just cut you off because I just had no sound and I flipped and
Yeah,
then
yeah, no, it's no problem. I was just saying that it'd be great if there was a bit of categorization of the talks, or like I see that there's a bit of notes here, which is nice. One thing I found was it's hard to know which talk to look at, and I didn't find nearly this long a list of talks. I found like a couple, and they were quite similar to each other. So yeah,
yes.
great to have that like on the web somewhere as a resource where you could like
So, this is filtered from 100 or more, 200.
oh
And
really?
and the issue with the repeats is I would take a talk and then present it and then realize that there was some stuff that was redundant or extra or not so appropriate and some stuff that I had thought was important but just didn't fit. So I rejigger and give the talk again.
Yeah.
So
So it'd be
any
good
one talk probably has five presentations of what they have slightly different things they cover.
right,
Give
right.
the talk 5 times. The third one's the best.
Yes. Yes. Uh, sorry, Derek, go ahead.
No, that's the risk with VC pitches too. It's like you do a bunch of practice pitches. It's like, oh, I got it really good, and then you go in front of somebody. It's like, somehow this didn't work out as well.
Yeah, right. Yeah. And then they do those get better too. It's all
Yeah,
good.
yeah, of course.
So like things depending on where you're at. So tales from the front line, startup war stories. You're busy trying to get funding or talk to VCs about stuff. You might find this one interesting. This is, me doing a bunch of startups in a row and having interesting successes and failures, interesting failures.
Right.
And at least looking some at the failures would help you sort out like, oh, when it's your turn to fail, you'll recognize I've seen this failure before.
Yes, that sounds good. I've
Good.
been through the ringer a few times myself.
Excellent. Excellent. Yes. This will be some new ringers, but no way I've found them all.
Good
Uh,
advice for your first salesperson, get someone who's good. Less actionable advice, how to do that.
yeah, exactly. That's really helpful for your partner. Make sure he's like sensible and sane and nice and stuff, right? It's like generic advice.
Yes.
If you're going to go to market, make sure you have something that the market wants. Thanks.
That was
Oh,
the problem my last startup had.
What was your last startup? I only heard you in big companies.
The last startup I was at was a distributed database where
Mhm.
you have multiple people who are all contributing information and you have to keep essentially the right logs so you know where every piece of information came from.
Right.
And the theory is if you have lots of organizations that all need to share a data set but don't trust one person to own and control the
Ah,
database, you want to all send all of the updates to everyone and all apply the transaction logs, but also be able to attribute for every single datum where it came from and who made that claim.
right. This is distributed ledger. All Bitcoins all the time or whatever.
And the problem is when you start talking to customers and they're like, right, we just hire a bank or a law firm to run it for us.
Okay. Yeah.
And we write a contract that says we all get access to the data
Right.
indefinitely.
Right. 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 Right.
And it turns
Uh,
out Postgres run by a law firm is pretty efficient.
yeah. Right. That's interesting. That's like, but yes, I get that we have this cool high tech idea, and then it's like this problem's been solved before for several hundred years.
Yeah, there's a lot of the ledger things that you're like, actually, you can solve this with law.
Uh-huh. Uh-huh. This problem's been around the block since the 1800s or 1700s or something.
Okay, okay.
Yeah. Law
Back to
has these
compiler.
extra
Back to
little,
compilers. Go ahead, Jack.
law has these extra little benefits of you know, just because you said something awkwardly or have a little bit of a bug in it doesn't mean that it all goes completely to hell.
Right. Right. Right.
It might cost you a bit.
The null pointer exception isn't quite the same.
Yeah. Doesn't mean that your bank account is now zero.
Yeah, and instead we go back and course. Wait a second.
So
Uh,
I've worked at a bunch of companies that have tried to make technical systems that comply with laws.
So
yes.
And I've learned that there's a word that the lawyers love and the tech guys hate, which is reasonable.
Right.
Make a reasonable effort to make this thing happen. Is this a requirement or is this not a requirement? What do you mean make reasonable effort that this happens?
Mhm.
That just means no retry logic.
Oh, there you
yeah.
go. Uh, yes.
Okay.
I don't know what else here.
Where
Compilers, go back to compilers,
yeah,
maybe.
where simple is going. at this at
Oh,
this
where
stage.
simple is going versus I was going to head down the discovery process at LLVM on a large code
Okay,
base
okay, that
where
would work too.
10 man hours were spent yesterday and the day before getting me to where I could debug anything in Hello World. It was just amazingly
10
bad.
hours, 10
And it wasn't
hours.
my fault. I sat there, did nothing, and three guys argued back and forth how to set up a debugger of any kind that would stop at a breakpoint and present, where you landed. And that was kind of like, this is eye-opening. Okay.
Wait,
Yeah,
why does GDB not work in this environment?
Oh, GDB, no, you have to use LLDB, the special data debugger for LLVM. They have their own debugger stack, not
yeah.
GDB.
No one was ever able to show me this for our compiler pipeline at Untether, not the LLVM one.
The LLDB or being able to stop at a breakpoint.
Nobody could show me how to stop anything at any breakpoint anywhere.
Well, that was my experience the last couple days. We actually got to a point where we could stop at a breakpoint. So it
Oh,
can be done.
okay.
Now, can I repeat the magical incantation on your hardware? Not certain. I have
Yeah.
one that appears to be working on the Mac that I got provided and was told you must use a Mac because LLDB works on it.
Out of curiosity, what are the reasons to use LLDB? Because I'm using GDB with MLIR without issues.
So I got the discussion of why LLDB. It's because it uses the same C++ parser as Clang does. So your expression parsing, when you type expressions at the debugger line, don't go through some weird GDB, I'm not quite C++. It goes through the official flavored. And the something about there was a back end piece that was identical, including disassemblies and other things. Like they robbed from the LLVM tool chain inputs and outputs for the debugger so that they could get a closer alignment to things.
Interesting. I
Now,
haven't really encountered any issues, but maybe I just didn't run across those parts.
I I would have said it should for what I wanted to do, which is break at main and print any local variable at all. GB should have worked, and it
Yeah,
could
that should have
not.
worked. That should have worked.
Yeah, it could not make it go. But there was some huge combination of Bazel producing binaries that Bazel got out of sync. So I hate I hate Gradle with a passion because it screwed up my one of my prior startups so badly because it was such a disaster and a nightmare and was buggier than fuck. My first experience with Bazel at Modular is it got out of sync with the debug binaries versus not the debug binaries. And I could edit and hack code and put a Cliff was here, printf, and I couldn't get that plus a debug version of it so that I could stop at the breakpoint. But other things had debug info and I could stop nearby, but not in the function I hacked a Cliff was here, although it was clearly running through it. So, you know, there's something else, not necessarily GDB, but huge amount of setup things going on that had to get magic incantations.
How's your
whacked
cycle
around.
time? I remember that was something you were always worried about.
Which one?
Like, how's your cycle time in terms of like from when you make the code edit to when you're looking at the debugger breakpoint?
No. I mean, they're like, it's so fast. It's like, it's not terrible, like 3 to 5 seconds. But
Okay.
I'm used to cycle times in fraction of a second, and I'll hack and hit the go and hack and hit the go and hack and hit the go, and it'll be as fast as that. So in 3 seconds, I'll have three goes.
Right.
Yeah, fine. We're getting there. It's progress, so I'll take progress. Hmm.
3 to 5 seconds isn't as bad as I thought you were going to say.
No,
When you
the from
3 to 5,
scratch
I
build.
was ready to hear minutes.
Yeah, the from scratch build is quite a few minutes. The incremental, I touched one file and hit go is, it's probably more like 4 to 5 seconds. It's not 3 seconds. It's several seconds. There's a bunch of setup things that haven't happened yet that may make this better. The default VS Code implementation, for instance, doesn't auto save files. So if I touch a file and I want to build, it didn't save the file.
Uh,
What the hell? Okay. And then
well,
the
if there's
the
anything I
the
hate, it's autosave. So I guess we're on a different page there.
I'm sorry.
one thing I hate more than anything is autosave.
When I go to hit the go run it in the debugger, I want it to now autosave
Yeah, okay, it makes sense.
and
Yeah,
then go
especially
build.
if you have the compile tool. So then you
Right,
know you're
right.
supposed to
So
save.
so we don't have the Bazel build yet in my VS Code setup running as an automated thing. So I switch to a terminal and do Bazel build, but that means I have to manually save in VS Code before I
Yeah.
switch to the terminal and hit the up arrow go again build and then go back to VS Code and say, okay, run again after
Can
you
you do
beat
it
the
with a
count to
file
three.
watcher?
I'm
Can
sorry?
you do it? Can you set up a file watcher like FS Watch?
Exactly. So these things all are doable. It's
Yeah,
just that, the progression has been days and days working on HR things
yeah.
and at least a full 24-hour period spent only on Mac versus PC keyboard things. And I'm just now getting to the point where I can build and run things. And like an hour or two to set up like hunting for symbols, by anyone's symbol hunting thing. And
Right.
okay, I got grep, I get C tags, basically grep. It took that a while for they realized, oh, we didn't include a bunch of the symbols from the base LLVM, which we are totally building on, and you call in and out of all the time. You have to have this set of symbols and that set of symbols. It's 300 gigs of symbols. I don't know. You can ask the AI. He will do all the searches very, very slowly. And then he will very happily, very cheerfully, oh, and you can do this and do this and do this, and now you work. And of course you don't. And it's so bad. Everyone's pushing the AI thing, and it has some things it does well, but
Which
things
AI thing
that
do you?
grep does well, AI sucks at.
Right.
Fine. Sorry,
Which
which
AI which AI tool do you guys use?
as near as I can tell, all of them. And I don't know who installed what. Like part of my
Well, like for
installation
instance,
instructions were download and install the following 10 plugins to VS Code, of which half were AI related
It
things.
does feel
Half
like
were
VS Code wants to convince you to use Copilot.
Cursor. Somebody wants me to do Cursor. And
okay.
Copilot was
I've,
one of the many things that was floating around. And
I've
there were
heard
several
Cursor.
more, and some of them were for pay, and I haven't gotten a penny's worth of work out. Now,
I've I've heard.
AI on Google searches for how to update the keyboard on a Mac to resemble what a PC keyboard would do, I found reasonable stuff. About 50-50, they were correct. And they sent me down paths that I would never have looked on a Mac and discovered the hidden symbols that this is why your F9 button can't be intercepted by Emacs and do the build like I've been doing for 40 years. F9's eaten by the Mac keyboard to do something that
Fast forward.
I don't need.
F9 is fast forward the music that you're listening to. Skip to the next track.
Yeah, right, exactly. A bunch of
You can
these. Oh,
switch it
yeah, function.
back
Okay,
to
the thing
function
turn
keys.
off the function keys that do media by default. And then you had to not eat F9 after you got it, the function button with an F9 while I'll do media things. Then F9 still got eaten to do swap the desktop or clear the desktop or something. It did something that I don't need.
Right.
And F10 and F11 and then shift left and shift right and control left and up down, blah, 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 blah. Like I said, I burned hours and hours and hours trying to get these things sorted. Fine.
It reminds me a little bit
So
of
I'm whining about
Facebook.
it. It's making progress. Yesterday
This
and
is
today.
your first time on Mac OS, Cliff?
I'm sorry?
This is your first time on Mac OS?
Yes.
Wow.
And
Welcome.
I can give you more fails for Mac OS if you want to hear them, but this is not,
Yeah,
this is
one of
me
the stories I
whining
liked
and
about
venting.
getting
It's venting
developer
now.
environment set
I'm
up,
happy to vent.
Facebook was trying to convert their entire ecosystem from PHP to Hack, but Hack had a compile step.
Uh-huh.
But they wanted to not break the workflow of all their developers who are used to PHP, where you
Yeah.
control S and then refresh the page and see the new behavior.
Done. Yeah.
And they ended up with a team of 4 people taking 2 quarters to write a file watcher that they felt could reliably and quickly watch files and trigger compiles. And
Wow.
they put an enormous amount of engineering effort into Control S refresh and getting rid of Control S recompile refresh.
Wow.
Wow.
What's wrong with
Yeah.
FS Watch?
Hmm?
Maybe
Somewhere
that's
you
what came out
intercept
of that
Control
project.
S.
I don't know if that's where FS Watch came from.
Maybe that's where it came from. But there's, yeah.
Like now there are good open source alternatives, but at the time Facebook was like, "Oh my God,
Oh,
we
yeah,
want a
okay.
consistent file watching experience on Mac and Linux and Windows."
Yeah.
We have to
Right.
write a project to do that. They were shocked.
Wow.
Yeah.
Yeah, some of these talks are like go back in time 20 years, and then I look at my talks and what I'm talking about and why it was important, and it's interesting. Yeah, things have moved on or drifted, and what was crucial has changed.
I will say, 10 years ago, I thought JavaScript was really going to take over the world because that save, refresh development cycle is so rich that it was just going to overwhelm all the other advantages of all the other languages. However, the JavaScript ecosystem has now put enough complicated, slow, bad compile steps into their ecosystem that it's fine, and all the other languages are competitive again.
Well,
Yeah,
if if
and you
development cycle
understand,
speed,
I press hard on that fast turnaround time. That's yeah, it's
I
the
mean, if
same reason
development cycle speed
everyone else
really
does.
mattered to most developers, then, you know, like REPL integrated experiences, like for instance, what I have in Clojure would actually matter to people, right? Like I don't even save, I just hit a key and the thing runs. Like,
It's something, yeah.
yeah. So
So my
So
standard Emacs build cycle, edit, debug build cycle is I hit the one button. I say it's the compile, but it's run as well. And then if I'm doing a GDB thing, it'll be compile, save, compile, build, run in GDB, bang the
the
button, pop.
interesting place we landed at TSAL, which was the firewall company, is that most of our production code was written in Scala, but most of our internal debug tooling was in Clojure. And when we
mhm.
would debug our servers, we would actually get a Clojure REPL on the server, which we would then use to examine the Scala objects, because it turned out the easiest way to engage with Scala objects was Clojure.
Wow.
Yeah. I mean, that's basically how I was debugging the compiler that Cliff and I built. Like I would go in with Clojure stuff. Cliff
Yeah.
has his workflow, I had mine. We made them both work,
But there
more or
was a
less.
there was a transition that was a little rocky. I
Yeah.
guess it got better over time. We
Well, yeah, it got better because eventually there was a front end that worked end to end in your flow. But
right.
at first, I had a front end that required you to have Clojure running, and Cliff uh,
It was too painful.
did not want. Yeah, he didn't want to have that. Well, there was some like startup overhead time, so you also had that roughly 5 second
Yeah,
lag.
right. My normal dev cycle would be go from scratch, go from scratch, go from scratch.
Uh,
And yours was start it once, leave it running. But then when you had to change something, you did have to go juggle back and forth and tell the REPL to reload. And at some
it,
point, I had too many
that
touches
happened only
at a time.
if I really screwed something up. So most of the time, I'd go honestly like days or even weeks without having hitting that. But every now and then, I'd be like, wait, what? Things are not working right.
I
And then I
claim I
would
had to hit
start.
that button all the time.
Yeah.
It might have
Uh,
been still a miscommunication on how best to do those things.
yeah.
The one that was interesting to me with mixing REPLs with running systems like that was the sort of capture one case, where you want to have a function where you can log in from the REPL and say, okay, the next request that comes in that passes this set of filters
Right.
I'm writing right now, grab that object, give it to me, and also continue processing it.
Oh, that's interesting. Well,
And we got a lot of debugging value out of the grab the next request where the user is this user and the API endpoint they hit is this API endpoint. And then you tell the person on the phone you're working with, okay, hit refresh now.
Yeah. And that's
wow.
actually not too hard to do because you just live replace a function with one that's got that conditional logic in it and it sticks a thing into a global
Yeah,
and
and
then
then goes
and
away.
then
Yeah.
yeah, and then once you've captured it, you can live refresh it back to how it used to be.
But the grab one from a running system, because you're capable of having a REPL. I mean, that was one of the things I was thinking about in the very early days when you were talking about AA. And that combination of a compiled thing that goes fast, but also having a REPL and eval there
Oh
is the
yeah.
ability to just open a port to your web server and say, I'm going to connect with it at Netcat and I'm going to have a REPL and I'm going to be able to poke around and ask arbitrary questions and debug. And like to some extent, GDB is a good debugger. And to some extent, the Clojure REPL's a pretty good debugger. And I
Yeah.
imagine the AA REPL would be a pretty good debugger.
That was part of the thinking for my head too. I just ran out of time and energy for it.
I mean, particularly if you can start it over the network. The ability to
Yeah.
show up and just be like, hey, I have this SSH certificate. And rather than SSHing into the box, you essentially SSH into the running REPL environment.
Yeah. Yeah.
You can basically do that by just opening port, right?
So
Tunnel,
one of the things I did
tunnel
it,
port in.
but I actually did it Sun, then it drug over to Azul was put an open port on a JVM that had a limited HTML response, query response it would do, but it dumped all the internal profiling data. But eventually I kept adding to it so you could poke and peek around the heap and you could start asking questions. I hadn't got to the point where I could take an expression and run it, but clearly it was basically a thread putting requests on a JVM through, through HTML. But as a means for like debugging what is the JVM doing and why is it having issues, it's just amazing. Get all the internal debug prints and what's currently hot and what's not, and where's the time going, what are the threads doing? Give me your thread stacks, all that kind of stuff.
Could you just throw arbitrary things into that stats pile? If I was debugging something, could I be like, hey, I want a, histogram at this spot. Please throw these things into the histogram. And whenever I hit the stats point, give me the current status of that histogram.
I threw a bunch of things in there, and then Azul put it behind a paywall and it disappeared. I was so sad. No.
But to me, that's a lot of the power that a JIT gives you that is underappreciated is
Yeah.
you really want to be able to eject arbitrary code at runtime. And I get why operations people totally freak out at that.
Yeah. On the other hand, the debug folks want to do it. The JVM TI, PI, DI folks all started from the zone of everything will interrupt, stop in the interpreter, run in C code to parse whatever, and then go back. And it took me, well, they had to pay the price before they realized that was just too fucking slow for profiling for sure, and too fragile for many other things. And then it became, oh, okay, we'll take some Java code or whatever, bytecodes, and then we'll inject it, and the JIT will pick it up,
Right. But
and
that's
now
one of
you
the
have a
beauties of
conditional
just
breakpoint being optimized, and it works, and it's fast.
if you just have a global object that lets you throw a histogram in there and you write a line of code at a particular place that says stick this number in the histogram. Here's how long the SQL transaction took. Well,
Right.
that gets optimized with everything else the JVM is doing. It's just part of the application code.
It's just part of, yes, yes. And you want to add and remove it. Yeah, yeah. No, that didn't happen for me, but that coulda, woulda, shoulda happened. Definitely. So these guys they use the word JIT a lot, Module use the word JIT a lot, but they're not thinking about or using the word JIT the way that we do. They have a late compilation stage of a full LLVM process when they know what their hardware is. But they don't, for instance, get profiling data that tells them what the common hot, fast paths of the large language model they're building for. Like it's all generic user decline fine configure bits that are coming flowing on the pipe, so the compiler doesn't see anything except a runtime value.
Yeah,
But
that's
in
a
fact, if you
Like
profile,
they're
you might
basic.
discover many of these are
They
just
are they are having to compile post distribution, right? You have to compile on the client machine.
yeah. But you don't
Yeah,
have
that
yes,
was something we faced it on Tether as well. It was really painful because we had the reason we had that is you'd have like specific uh, the chip had like thousands of processors on it, but there's a couple that are defective, but they're in random locations.
right,
And with the spatial architecture, you need to
right,
like row around them. So then you end up with this whole like, one-off thing. So it's like kind of every chip is a little bit unique.
right.
Super annoying.
That
You know.
sounds reasonable to me though, that you would have that and that
Yeah,
you
except for that the compilation time is really long. And you had to do it not just one, like if you're deploying onto 10 chips on the client, you have to compile 10 times, or at least do
10
that
different
some
chips,
save 10 times, right? So
10 different bad
it
spots in
was
the chip.
bad. That was bad. That was a bad thing that no one ever figured out. Um,
You just need a faster compiler.
yeah, exactly. A faster compiler would have solved things, but
Fine.
had a. I'm not going to say anything further.
Yeah, that's fine.
So moaning.
Yes, exactly. I mean,
blaming
I saw
individual.
some red flags early on, but it was a fun piece of work, so I was happy to do it.
Yeah, well, that's sort of
Ran out
me
when it
too.
ran out.
I mean,
I mean,
I was enjoying the work. If I hadn't had that specific work to do, I would have been out the door long earlier.
right,
So
right, fine. All
There was
right,
a
that's another
funny
tale
story
for the
with the
Tales from the Front
really
Line.
early simulations that General Motors did for their engine flows with the craze,
Hmm.
because they had a huge number of cells that were all connected to each other. And because of a quirk of their simulation, if one of the CPUs died, stuff would just propagate straight through the section that was owned by that CPU.
Hmm.
So you could tell that you had one of your CPUs that had failed because all of space now had a curvature to it that would throw all your fluid stuff. And you get these weird turbulent arcs of things going in big circles because one of the voxels of their spatial simulation was just gone.
Just gone. Interesting.
And they talked about all the error correction, error detection stuff they did with the early craze to get those things to actually correctly simulate fluid flows, even if some of the CPUs weren't there.
right.
Interesting.
Yeah, it doesn't seem like a very good failure state. Oh, I can't, I failed. I'll just pass on the source data as an output.
Well, the whole like chopped a voxel out as opposed to hang, waiting for the reply that it changed, or I don't know what, do something. I would not expect
You
an
don't think a missing
invisible.
chunk of space-time is the appropriate response to a
Yeah,
failed CPU?
yes,
Could be.
fine.
Maybe that's how black holes originated.
I don't know how they compile it. It's a dead CPU in the simulation of the universe.
Yeah.
You put too much mass into one spot and it overheated the CPU and burned out.
Yeah, yeah. And a supermassive black hole is when like a whole rack got disconnected.
All right, all right, all right. Are we going to talk compilers at all today? Or are we talking startup death, which is its own entertainment? It's useful.
So I like the conversation of how tooling interacts with compilers and JIT versus ahead of time leading to different kinds of behaviors.
There's certainly a mind change going on. These guys have this hardcore, it must be ahead of time for performance, but
You
they're
talked
throwing
about.
away a lot of performance by demanding ahead of
How
time.
much
And I,
how much JIT is possible on like a given GPU? I mean, you don't necessarily have all the info you need, do you?
you mean running the JIT on the GPU, which I think would be not be a good.
Running it, but like, are you going to be able to get the information you need in order to
The,
know
Can you get the counters out?
these counters? I don't know.
see, here I don't know, but I assume I know you can get stuff off a GPU. So if I wanted to get profiling data, so some of the profile data shows up very late in the pipe, but it's driven by the driver into the GPU, which means the CPU has it, the size, dimensions, layouts of the matrix multiplies that are being pounded through. He knows that shit on the CPU. He's just not going to do the volume of it.
Yeah.
So I think you could get it
Oh,
there, but in theory, some of the GPU generated code could bump a counter every iteration, every whatever. Can't be that expensive on a GPU. And then you have to run the counters back out. And like I said, it seems plausible to me that you could pick these counters up and now turn around and do something with them. That some of them are very the where modular's headed, everything's statically computed on a GPU ahead of time. Um, but it's computed late in life. So when you land on the Docker image that's going to actually run on the GPU in the Amazon cluster, you find out what GPU you got. Then a bunch of things that are runtime values become constants, and you re-constant propagate, re-inline, then you tile. So all the blocking and tiling changes. There's a lot of work happens. That's all done in LLVM on the x86, and then you hand the thing over to GPU. Now, is there more refinements where I have things that are expected to be runtime, except in practice on the GPU, it's always 1, 0, 1, or many, right? That turns out to always be one of the 0, 1, or minis. You might be able to make some progress with it.
I wonder if some of those same bailout tricks will work well in that context of here is a code path that we rarely go down.
Yeah.
If you go down it, throw away all the work you did in this batch and start again with the.
Yeah, a different version of things. There could also be we went weird here and we'll run to the end and take what we get, and also we'll raise a flag back at the home CPU, and he might rerun that on the x86
Because
to deal
historically,
with the corner
GPUs have
case.
shied away from that kind of dynamic behavior because they're trying to hit 60 frames a second. You can't bail out and retry. You have to know that your worst possible path through your code is no
Yeah,
more than a 60th of a second because you've got
yeah,
60 milliseconds and then you need to
right.
render the next frame.
So most
And
of
for
what
AI,
they're
that's not really true.
yeah,
Aren't
mo
aren't
most of what they're targeting is outputs of the AI to a human who's reading and who will just wait a fraction of a second if you're a fraction of a second slow producing the next syllable.
So if you're 16 milliseconds late, that's fine.
Right. It's not such a hard real-time number. Real time always has these ranges of when it's important and when it's not, or more or less, or whatever. The things that guide a Airbus have a certain speed range, and things that do your car CPU have a certain speed range, and things that do my pacemaker have a certain. No, I don't have a pacemaker. Right. But
but
some
the
things matter more or less.
Yeah, but like with the GPU, you also have to always keep in mind that you've got some number of copies of the thing running in parallel. So one copy might be doing something weird, but the other ones are all on the regular path. And aren't they all doing a kind of SIMD like
Yeah, they're
thing?
all
I'm
going to
not
be SIMD.
exactly
Yeah.
sure. So
So
like,
weird in this case probably means that you got to the end of the chunk of code you're running, and all the blocks have something useful, and one block has a flag in it saying, I borked halfway through.
right.
At least I would imagine that's how it goes. So this is the part where I'm here to learn it. Modular. Go
Yeah. I
find out what goes on.
I kind of thought that if you've got like a special case, then the time that the special case takes is added to the time of the common case for everyone every time.
Yeah. Yeah.
Because you go through all the logic of the common case, but some of them are masked off.
Hmm.
And then you flip the mask and you do the other case.
Yeah.
And it's sort of like they're like one behind the other. And you really, you, it's kind of like doubles your workload
Yeah.
across the entire
I can.
like thing. I don't know if I don't know if there's probably something for that in GPUs.
There's some room to be more dynamic there where you take all these special cases and run them somewhere else and get them out of the common case who can now chomp the fast path without
Right,
having
but it's
to
just
deal.
different. The graphics case, you wanted to do the same thing every time and render the scene and always hit your frame rate.
Always at your mark. Right.
One of the common cases you're going to see in these GPU is I'm doing a needle in a haystack search where I'm trying to read through gigs or terabytes of data
Yeah.
and I'm reading it a couple of thousand characters at a time. And the thing that I'm running through my GPU is 4K of text, and I want to process that 4K of text in,
Yeah.
a millisecond.
Right.
And if I found the needle in the haystack, then I want to bail and reload a new model that actually reads that document to try and answer the question once I've decided the topicality of it.
Right.
So like it has this retry thing, but it's at a kind of higher layer. It's not like one pixel or one word is going to fall into the common case. It is in some sense the aggregate of the processing of the entire context that
Well, I'm
is going
Yeah,
to trigger, okay, now we need to go compile the new path.
you probably don't want the GPU to be like look at a page of data and see if there's the needle, let the CPU know, and then the CPU's, and then it says, nope, there isn't. And then it's like, okay, give it another page. No, no, you want the GPU to be streaming the pages as fast as can, and asynchronously eventually pop out with, I found it. Meanwhile, it's still streaming pages, and then the CPU can say like, okay, quit.
The H2O did that. That was it was
Yeah.
you stream and you're looking for the top three, the bottom three, the median, the mode, blah blah blah. Everyone was streaming through all the time, and then at some point you started gathering outputs from people, and some of them said I have it, and some of them said no, and you had to do reductions, and the reductions could be on the CPU. They weren't throughput related. They were log tree values of reductions compared to the bulk. You know, The reductions were the log of the size of the data involved. And so you didn't care if you moved over to the CPU, you're already so much smaller.
There was a research project that fell into a case like that. So the JVM tends to assume that anything it's seen before can happen again.
Yeah.
And at the very beginning, you're saying, hey, find me the best solution you have for this class of problem.
Mm.
And it's like the first one is the best, and the second one has got a 50% chance of being the best, and the third one's got a 1/3 chance of being the best.
So
So when
there,
you first start, you trigger the exceptional case all the time. But then after 20 minutes, you're probably only going to find one every 20 minutes. And after an hour, you're only going to
yeah,
find once an hour. And after a week, you're only going to find once a week. How do
right.
you know it's time to like clean that out and start over and recompile the function now that what's rare has
Right.
changed?
So the accidental behavior is that shit happens and triggers recompiles. So in the beginning, you get all these weird cases that are all just running the interpreter, so those don't count. That just the interpreter just runs. You don't care. Then you get some tier one compiles, and you gathered some stats, and they led you to try a tier two compile. But because tier one ran a little while, you got some of these ratios that were on this asymptotic drop off. You said they dropped already by the time they got out of C1. So C2 didn't include the bad thing. But if you still had the bad thing and C2 was doing it, the accidental behavior was something else changed after a while, and you got a borked recompile go again. And then on the next go round, you were already below the threshold and you didn't.
Right. So that works if your behavior got more diverse, because the more diverse will hit the case that you didn't deal with and retrigger. My question is, what happens if over time you get more consistent?
Right. No, that's what I'm saying. It was the common case that something else that was an unusual event while you're heading down, you're trending towards stability, something else would just pop you accidentally and you would go. It wasn't a perfect solution. There was discussions about forcing recompiles from time to time on things that seemed to be going well to see if we could get new stat data that said something. One of the issue we tried this a bunch. So one of those like profile counts that were they were basically rolling averages with an exponential decay on them. So things that were in the misty past eventually fell off and got thrown away. But you had a front weighted loaded rolling average of the last in minutes, whatever the number was, and then you would trigger compiles. It was actually being used to stop compiling because some of the earlier compile teams, I fought this one, were like, no, the rate at which this function executes is so low, we'll just interpret it every time. It triggers the 10,000 point, but only after 5 minutes. So the incremental performance gain, but also I was like, but the incremental cost is also, so just do it. And then the same thing was like, we've been running a while. Let's at least rerun the stats from fresh and see if they looked like the stats we used when we compiled. And kind of difficult to show a real performance gain in the common case. It was unusual that supporting the initial fluster cluck that you were talking about made the long-term code so much more egregiously bad that you actually got a reasonable gain out. So the sum total of all the things that could be bad that didn't happen and were done optimistically was much greater than the actual set of things that were done crazy in the beginning and then stabilized out. It's kind of where it came down to.
And to some extent, the 10,000 runs in the interpreter helps with that, because a lot of things will have already
A
stabilized.
lot of things just yes. And when you
Um,
went to C1,
Whereas a
that's it.
JavaScript 3 runs through before you do the JIT is
I get that. I'm just saying that for the next tier, I would wait, 10,000. So it's exactly the same thing with C1. So the interpreter runs at a certain speed. Well, C1 runs a lot faster than the interpreter. And in particular, it can profile more at a much lower cost than the interpreter can profile. So you really want a tier one compile in there after a while and gather a lot more detail. And then now you can get to like 100,000 iterations and they'll still be much less cost than what you had before. And then by the time you get into C2, you've gotten a lot more data. So And that's what you just said there with the JavaScript. Yeah, the third turn around, we did the first trace and we got it going, and it's great. And I had said, and maybe they do after 10,000 runs through the trace, do it again. See what's changed.
Yeah, I kind of want to be like, okay, compile it after 10,000, after
I know
10
they do.
million, recompile it again, and then after 10 billion, recompile it again, and
Yeah,
then after 10
I
trillion,
want to
recompile
say
it again.
they have 3 and 4 tiers on some of these JavaScript engines. They go again after a while. Yeah, yeah.
The use case that I'm thinking of is Twitter used to have some services that some turbulent thing would happen, and a service would start throwing a bunch of exceptions. And then it would handle all of the exceptions. And then the transient event would be done that had caused a bunch of exceptions,
Hmm.
except that the number of throughput requests per running instance would have dropped because now you've got all this exception handling code in the iCache.
Yeah, and I'm wondering if is that where it actually was? Was it actually so much exception handling code? Because the iCache stuff just flushes out. So it's not that it's in the iCache, it's in the generated code, such as
Right,
it
the
triggers
generated code's
in.
just bigger now because it's
It's
got
just
the
bigger. Yeah.
exceptions in it.
And you're touching the hot path you're touching includes fractional lines that have exception handling support on them instead of just being raw data
Right.
and raw execution code.
And it wouldn't be able to keep up, so it would start more instances. And you would see that the new instances that were being started were holding more throughput than the old instances that have been up for a while. And we built a detector that basically said, if you have a service where a small fraction of the newest instances are outperforming the average, start killing the old ones and restarting the JVM with the new ones, and the scheduler would just roll through them, and then you would get back to stable throughput, and the number of servers that were doing that work would go back down.
That's, I mean, this is like shades of me and the whole
Um,
refs versus GC thing.
and like it totally worked to just detect, hey,
Right.
you started 8,000 copies of this service, and 2,000 of them are much slower than the others. Restart those because they have some state they don't like.
Right. And yet there is, long known thing about the JITting of there's this JIT plan. It comes about randomly according to the timing and spacing of events that have happened and then profiling on. So what
You
you're
think that
doing.
probably doesn't justify a change in the JVM to try and detect? I guess the
Um,
problem is we were able to do it because we had the higher level perspective. We could say this running JVM has got a better stable point than that running JVM, so I knew that there was some state there, whereas the one JVM has no idea.
has no idea. Yeah, and I would have, had I gone there, had I been there, I would have loved to have sorted that one out. It was things I
I mean,
kept hearing rumors of.
wouldn't a nice approach to something like that be that you just have a signal that you can send to that JVM that says, "Oh, look, the user thinks I need to restart my counters."
If you had that, why not just the signal be Control C restart?
Yeah, I was gonna say we have that signal. It's called sig9.
Yeah, right.
Yeah, yeah, but then there's also the extra costs of restarting. Like, if depending on how your caches work or whatever, you might have extra restarting costs.
Yes, that's true. Part of the reason this was so cheap is that a lot of our big memory consumption was in memcached, not in the JVM memory. If we had big caches in the JVM memory, we probably would have been more hesitant to restart it.
That's interesting. Yeah. So, I mean, you could do such a thing, Derek. That wouldn't be, there wasn't one baked in. I could do that. Actually, my HTML hook I threw in the early JVM, early Azul JVMs, late Sun, early Azul JVMs. I had hooks for doing various cache reflush things. I could have forced a compile.
A all compiled code flush.
You want to do a rolling flush because it's a big hit if you kill it all. But you could start a rolling flush.
That's true. I don't
You
want to
want
delete the old one. I just want to say start compiling everything again.
Well, I hear you, but you want the profiles of a more recent time. I would have said take
Well,
the eldest compiled whose profile base was the oldest and start popping them sort of one after
it's
another.
it's funny that you say I don't want to delete the old one because the existing solution of killing this process and starting over is pretty much doing that.
Yeah. No, I'm saying, yeah, I was saying don't delete them all at once because that's a big performance hit. But definitely kill them all, but roll them through. Which might, yeah, I don't know if it would have rescued the thing. I'd have to go stare and believe because one of the things that came with the exception handling mindset thing stuff, whatever, was a careful layout of how what was common and what wasn't, so that exceptional code was never in a partial cache line that would go into something. You would always, the exceptional code would always be the branch that you tested went off to an unrelated cache line. It was supposed to be done that way.
And that was about counters. You didn't care if it was actually an exception or an if.
Yeah, yes, it was all profile driven. I looked at the branch. The branch said I go 99.9 this, some that. Okay, twist the branch around so that the flow through is fast, and the target you go to should not be a fractional line with some hot code. It should be its own cache line. So you just a little padding.
That was one of the things that always amazed me when I would look at profiles from the JVM is just how much of the code is cold.
Yes, yes,
And you're like, we need all this code. It's not like we could just delete 80% of our code. Why is 80% of our code super cold?
yeah, yeah. You could argue that C2 kept on compiling when the profiles got low enough, you should have bailed out. And then there was the bailout paths often had to rebuild state that was only in the optimizer's head. So you had to have something in the bailout path that rebuilt state. You looked at me funny, but like,
I don't understand what that means. What kind of state
okay,
is
if I
only in
if
the
I threw away
optimizer's
an
head?
object, so escape analysis says I had this object, I just made it new, I'm going to do something with it, and then I'm going to be dead. It's going to be gone. So I in-register the whole thing. In the middle of this in-registered piece of code, there's an explosion, and I jump off to slow path. Now slow path has to allocate that object and then populate it so that the interpreter, when it picks it up, actually has, yeah, has the
The
object.
interpreter needs like a hash code header and stuff that
Don't need
just didn't
like
exist in
derived
the optimized
pointer.
version.
I have a pointer in the middle of an array, I have a hot loop, a pointer in the middle. The base is somewhere, but the actual index that says which array element, that's gone. And when I swap to GC, I will diff these two and scale, and now I have an index, and the GC does its thing, and I rescale and shift and go back. But if I deopt, same thing. I have to I have to unscale this, reverse it to an index, put it somewhere, and then you said code, but there's
That
going to be a
sounds very
butt ton
fiddly. Were
of.
there a lot of bugs in doing that?
Not anymore. Those went away a long time ago. So it's like blah 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 lot flags. There are a lot of these blah 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 lot flags. There was a rare path that you had to be there for correctness, but it was rare, and the fast path was the common case was fast, or you screwed up. The common case is slow, you're screwed. Okay, the common case is fast, which means that your uncommon case has all this weird shit, and then is that correct? So blah 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 lot says, oh, bail out of the common case and check that you can, yeah. And we went through those and found those kind of things. The deopt the derived pointer ones um, went through maybe a slightly longer bug tail than some of the other things because you had to have a GC cycle. You had to stop because of a GC cycle and move the base of the array, and the derived pointer didn't get moved because it wasn't told correctly. And so the math didn't happen to shuffle it. Okay, so the rare case is an array moves. And in fact, the arrays are big, and then big arrays are disencouraged from moving by GC because it's a lot of work for little gain. So it was a little longer bug tail for things around that one, but they sorted out. I can probably even find now in my Java 7 source code places where the deopt and derived pointers collided in bad ways, and I had to have some hacks in there. Wait, check for derived pointers. Made the register allocator have an extra thing it did. It slowed the register allocator down by a tiny but noticeable amount to recover that case.
So if the JIT's ability to pull a bunch of code that is very rarely running out of the instructions that are in the instruction cache and lose less memory bandwidth and get all these wins,
Yeah, yeah.
Why is C++ ahead of time compiled code still competitive with the JVM?
Oh, because they do other things that are higher payoff and higher compile costs. So there's this tension, right? I have compile speed issues. So I threw away a bunch of things that have minor gains for big costs for minor gains. Well, so C++ pulls a lot of those. It's 100 times slower. Okay, say 10x slower is because they've just like screwed up and they're fat and bulky, and then 10x is because they run a thing and 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 a little here, a little there, a little there, and they get some gains. Okay, those are interesting.
That kind of may be the trade-off between the JIT compilers and AOT ahead of time compilers. Like, I remember in the 1990s, there was the thought that JVM should outperform C++ because it's going to get all of those hardware-specific optimizations, all of those profile data, all of those statistical
Yeah,
thunders. It should be faster, but the trick is that JVM never has the time to do very heavy-duty optimizations at runtime
yeah,
because then you would pretty much kill the interactive performance of the application or even kill latency to the point of killing throughput. So C++ compilers, it's not necessarily the language, it's just the function of having ahead of time compiler that can spend a lot of time compiling ahead of time.
yes.
That's basically the
But
trade-off.
I will say, having studied this problem a lot, is that the JVM gets really, really close, or profile goes a long way. It gets really, really close to exceeding commonly, quite common for JVM code just be faster than what you can get out of C++ because you just don't have the late arriving profile data. And
Yeah,
there are times when the
probably
reverse
depends a
goes.
lot of the workloads too. Like if your workload is stable enough, you can do something like bolt, which is the post-link time optimizer, which can move basic blocks around and can move code basic blocks outside of the hot path so that your
Yes,
instruction cache is utilized. And
right.
that's not gonna hit any problems as long as the profile, the PGO that you use to do this basic block optimization stays stable. But that's also kind of adaptively true for JITs, because if you have a really unstable workload, you would be just de-optimizing all of the time, and at some point you would even exceed the threshold where you would probably stop optimizing or throwing heavy-duty optimizations at all.
It-
So it's kind of there is a probably a sweet spot where the JITs have to outperform when the application takes maybe a long time to stabilize, and you wouldn't capture this with PGO. But if the workload is really stable, then you're also gonna capture this with PGO. So it's a bit of a curve, I would say, where one can output from the other. It's not straightforward line.
I'll agree it's not a straightforward line. Certainly, Hotspot has all those things where it counts the number of deops for certain things and starts to become less aggressive if it's deopting too much. There is a oh God, get something that works path, and it just gives up on things that it's having trouble with. Um,
I mean, is there a path? Are there paths potentially where you say, okay, I've hit 10 million uh iterations on this code, so I'm going to do the more expensive version of the compiler and sort of pull in some of those things where it's
right.
high cost and relatively minimal gain.
That never happened explicitly. We were just talking about this like earlier in this call. Accidentally, we would get reprofile and rerun late in life for hot code. It would happen. It happened fairly enough on big applications. On small micro benchmarks where the hot code is very obvious, I'm doing Saxby, Daxby, BLAS operations. No, never. But for big methods, big codes, yeah, it happened. And then you got new profile data and you did something, but you wouldn't necessarily do
What I'm saying though is like, is there a point where you say, I'm willing to do a really expensive JIT operation, and I'm going to take as long on this
right.
in the JIT as GCC would, and do all the stuff that
I hear
uh,
you. I'm
yeah,
saying no for C2, but yes for other people at different times. Like Arthur's not
yeah.
here, but I'll just be damn sure that he's got that version going on in Falcon.
Because these days we got a lot of CPUs. If I can just hand one CPU and a chunk of memory and be like, hey, this thing's going to be running for
Go.
two
Yeah.
weeks.
Do something.
Run compiler experiments.
Yeah. Yeah.
Don't do the thing that takes an hour initially, but
Right.
maybe once you know you've been up for 30 hours, it's time to spend an hour compiling a real version.
Yeah. Yeah. Absolutely.
So
Yeah,
what would be an optimization that would yield more than just the fast approximating optimizations? What would be such a kind of optimization that would yield much more gains?
So when I walked away from C2, I did every normal thing that you would do except register tiling and blocking. And that was just because the optimizations they just needed enough extra energy, and that was,
Register tiling and
and blocking.
Don't know
blocking.
what that means.
Oh, matrix multiply, which is defaultly in cubed, visits memory in squared. But you can arrange that the squared visits are all in like L2, and then smaller chunks are in L1. And so you divide the squared cost by 10 or 100, depending on where it landed. So I have this big matrix. It's too big for my caches. Um, but I'm going to visit everything in this chunk over here, and this, and this, and this. So these 4 chunks, each one is going to get visited in squared. Well, if I put this in my L2, then these in squared visits run at L2 speeds instead of memory speeds. And then within this, I divide it again, say by 4, but whatever the right divide is. And this little guy fits in my L1. And then I might divide it again into registers. So you might have 3 tiers of recursive descent drop downs. And then that tiling says that each of these different things happens at a 10x faster speed up versus whatever, versus the default case where I just said of the big matrix, walk, 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 and then next one over, walk, 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 and next one over, walk, 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 walk. So instead of here I do dit dit, and then I do dit dit, and then dit dit, and then dit dit. Well, these were all in my L2, and then within this section, it was the L1, and so on. So that's
And that can be
tiling. And
detected
then
without the code explicitly being written to tell you how the blocking goes.
so in the case of Modular and Mojo, you're expecting the program to come up with those dimensions based on the GPU hardware, which is late in life. So there's some complicated algorithm going to run, and then they're going to say, okay, this is the blocking factor for here, 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 here. And because these things have to be joined, I'm going to do whatever. And if you go down to matrix multiply specifically, which has been long beaten on, there's like not just in cube, but into the 2/3 fractional blah, 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 where you get a more fancier visitation algorithm.
And you
And it's like
cannot approximate that.
FFTs
You
have
cannot
this.
approximate that with cheap information that you have in the JVM.
This is a thing that you get as soon as you know the dimensions involved of the hardware's CPU caches and the size of the matrices you're dealing with.
But that you know it as soon as
Could
the
know
JVM
this.
starts. We're talking about some optimizations that can potentially yield more gains, but they are longer to get.
So I'm saying this one has large gains on it.
Hmm.
Doing tiling operations has integer factor speedups versus not. They're 5x, 10x, I don't know. There's some big numbers. I didn't do them.
Hmm.
Now, had I known that I was going to look at these kind of workloads at some point, then I would have gone down that path. But I did other things because Java had other problems to be solved that were not.
I would also imagine maybe heavy loop vectorization, but not only the vectorization itself, but also the long sequence of analysis that you would do for this loop vectorization. Like the scalar evolution analysis in LLVM, that's far more advanced than the induction variable analysis you get in the traditional compilers. That possibly takes some time. Maybe not a huge time on its own, but when you have like a dozen of analyses like that and then all build up to information that you then need to do to the optimization, this all adds up.
So I did the easy first cut of those, but I didn't do the long tail of them. So I could do like simple stencil calculations would do the exact thing that you'd expect a vectorizer to do. But anything beyond that, I voted out.
That being
And in
said, nowadays
particular,
with MLIR, it would be much easier to do vectorization.
so in particular for Java, you had to also get the GC to not break up square arrays, right? The language allows ragged arrays.
Oh, right.
And so right. So there's a thing there. The GC guys can say, we put a bit somewhere that says this is a square array, or it's a subfraction, an internal piece of a square array. We can find the base of the square array. If we're going to move it, we're going to GC it, we're going to take the whole square array and leave it square. And it could still be all Java objects, all whatever, but you know by inspection of the object header, this entire array is square. All subarrays are all perfectly uniformly aligned in the same width, and there's some headers in the middle, but I'll just skip them as part of the array math, and I don't care. That will cost me nothing.
Yeah,
And
you
then
wrote an
the C2 would
array
accept.
list of array list of point, and it looks
Yeah,
and goes, I think what you mean is two-dimensional matrix of point.
yeah, exactly. It would be, now I know you're 2D. So the first thing C2 code would do is say, test, are you a square array? Yes, no. Okay, no. Okay, fuck you. Yes, okay, now I have a 2D array. Now I can tile and block and screw around. But I had to get the GC guys to do that. And we all had our own problems. So we ran out of time, but there is a technology that says we could do this. So for things that look like large HPC calculations, there was a missing piece before I left that could have solved and allowed me to
Yeah.
make progress.
Even if you only got that right for matrix multiply and fast Fourier transform, it would
I would
be
need
huge.
a pre-pass that ran over the array to confirm it was. And I could have done that actually. Honestly, the speedups are big enough; it would have worked. That was out of time, but yeah, you could do that. Walk the array,
I wonder if this
confirm
stuff is showing up in Graal. I mean,
So,
I haven't heard about things like this, but now that you're talking about it, it's kind of surprising me that it's not. But then I may just have not heard it.
I talked about it occasionally to people. I didn't push on it hard because it required this whole JVM thing. See, the penalty here is that the GC guys have no uh, um, they have no motivation to preserve the squareness of the array. So it's only accidentally that the array is square. As soon as the array is not square, all these fun transformations just don't apply. So you want to do this thing, it's going to give you double X faster matrix multiply, double X faster FFT. Well, you have to talk to GC guys and doing it. Now, when the GC guys do it, it's probably not a huge deal for them to do, but you got to span across teams, or it just didn't happen before I left.
So the only compiler I know of that I've heard people doing that in was the APL compilers.
Oh, Fortran everywhere.
Fortran used to always do that.
Oh yeah. There's no chance of not being square. C compilers and Fortran compilers all do I mean, I've known this forever. So I came from a HPC computing PhD thesis background. The main guy at Rice was Ken Kennedy. He was doing high performance computing and super vectorizer everything. And his first grad student, Keith Cooper, was like, "We could do better at scalar computation." And boy, could you. And I was Keith's student. But I had steeped in the background of how to do giant vectorizing, matrix multiply, whatever, how all these things worked.
I bet most of that stuff's in NumPy,
It probably is.
even if it's
But
not in the actual Python compiler. People who are actually doing that kind of big matrix multiply kind of stuff in Python
oh,
aren't
they'll
doing it
call
in
it to
Python.
see
They're doing it in
multiple
NumPy arrays.
laws or whatever. Yeah. But it can be done in the GC with a little help from the GC guys. So your thesis, Matt, of performance gains in the HPC community, there's a big chunk of things I'm missing. But in the non-HPC world, which is all the normal Java app crap, which would, if you were comparing against normal C app crap, I claim that I almost surely have got identical optimizations left and right, plus profile data.
And my guess is the C++ guys are doing a lot of that just in code.
I get to, the profile lets me cut some things out, but like a thing that happens with profiles that C++ can't do is to say, I have a class hierarchy that in practice is only one implementation, and in theory could be anything. Like you read a config file and you said, oh, I'm using arrow layout swing colors as opposed to theme dark or theme, I don't know, mutable, I don't care what. Only one of them is picked by the user at the start of their application is the same all the time. The profile comes through and says, no one ever loaded anything else except this one. So if you say, give me the theme for the GUI display, blah, 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 he says, class has one implementer, abstract, abstract, one implementer, and then this whole chain all disappeared. He says, okay, he's only ever this guy. And that's a real common thing. The startup config gets read and things. The same for libraries. You have a library, it handles all possible things. But
Yeah,
in
all the
practice,
logic that's like switch on CPU type, switch on operating system type,
yeah,
that'll all just constant propagate away.
it does. And that's what, I mean, totally C2, like exactly that one. That one's special because we know mem copy depends on cache lines and alignment and prefetch and blah blah blah. And that one for sure gets picked up. But no, like the runtime, like how many CPUs do you have? That's assumed to be a constant. And then if it is written as a constant, which people in the libraries do, I don't know specifically, but if you then C2 says you have a final constant in a class, I'll treat it as a constant. And then it jits out. And that's
Do I
what
need to tell you it's a constant? Isn't the fact that it's slow moving mean you'll figure it out anyway, just because it didn't change during
No,
the first
I have
10,000 iterations?
surprised of a slow moving memory field as a cool optimization that shoulda, coulda, woulda, but I never implemented that and I don't know it ever did. But there are tons of, I would call it non-constant slow moving fields in large Java apps. Tons of them. The other one that's tons of is fields that are only ever null. They're not, if you don't do a whole class hierarchy analysis of all the possible ways that somebody can get to a field, you may not realize it's null, but you can totally profile that no one has ever written anything into this field ever. And then if they do, then the interpreter picks it up. The code doesn't compile at DOPS, and the interpreter flags it, and you go recompile. So wait a second, it might not be null. But if everyone agrees it's always null, maybe I can shortcut even shrink the field out of the object and all kinds of fun. There are
Yeah.
opportunities here left and right.
But there just are a lot of things that are genuinely slow moving.
Yeah, yeah,
There's a bunch of code paths that are like, we only go down this code path if we have lost communication with the other data center.
yes,
Most of the time, you're not out of communication with the other data center.
yes. But that one gets caught because the fail code is another class. And the JIT says no one's initialized that class. So it's been loaded in the system. It's not initialized. Ain't no instances floating around. No one's going to call here. It can't happen. Deopt. Bam. So you get that one.
Yeah, it's only in the moment that you're like, I can't talk to the ranking ML, so I'm going to run a local ranking model that's tiny and fits in memory. None of that stuff got instantiated until you lost
Until you lost it.
communication
Yeah.
with the big
Yeah.
one.
Then you're paying the JIT as well. And also you're running with very little profile data and all that kind of other stuff. And, it happens. The high frequency trader guys all bitch and moan about this. And then Arthur's not here. He can talk more about it, but they'd have things where on opening at the Monday morning open, there'll be some set of guys trying to, I don't know what you call it, there's a term for it, but they bang it on the exchange at the 8 a.m. number time in an attempt to slow people down so they can dump things based on whatever happened on the weekend. So they're trying to, on purpose, screw with the exchange. Well, everyone else is detecting this. Oh, so Jojo, blah, 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 is like spamming the exchange over here so he can dump over there. And we're going to do the appropriate counter strategy. But that's all weird one-off code that only happens at the very start of the exchange. And so when we start up our high frequency trader JVM, but that's a conflict there, we have to be prepared that as soon as the go button hits, this code is jitted and hot and ready to go.
Yes.
We talked a bunch with them. I don't know. I mean, I'm now 10 years stale on that, but there was a lot of discussion about standard warm up for the middle of the day, but the start of the day and the end of the day warm up as well, because they wanted those to, those algorithms to be hot and ready to go.
Yeah, there are a few things like that in JITs that I feel like there's a series of handles that should exist in the programming language so that you can make the compiler do certain things, and
Yeah.
also you shouldn't use them.
They will be abused
Like, I
all the
just
time.
want to tell people, like, here is your this must be ahead of time compiled bit that you can use for these things. But also, you almost certainly don't want to set this. The JIT will make smarter choices than you will. Only
But
set this if you have a data science team that said it was right.
back in the day, there was the register keyword for C. And then it had its day, and then like register allocators would always beat it. Then there
But
was
was
the
that
inline
the
keyword.
register keyword? Is that it must fit in a register, the value?
Yeah, and you can't take the address of it. It
Hmm.
has a meaningful
Cool.
computer science engineering effect of this value will only ever be a value. It has no memory address. You can't accidentally force it to get an
It will
address.
be by value always because it will live always in a register.
Exactly. Except the semantics at the time it was written was it would be in a register and you better fucking honor that, which,
Hmm.
like I said, had a lifetime of a couple of years before register allocators all overtook it.
There's also this amusing story of frequency. So one of the first Fortran compilers had the frequency statement, which is a little bit like a likely annotation for the branch.
Yeah.
And they discovered they got the implementation exactly wrong. But it turns out that was no problem because the users were getting the annotations exactly worked. So it all worked out in the end.
Yes, I've heard this one too. Yes, same. Yes.
If you allow the users to control the behavior, they will abuse it. So
Yeah. This is where Mojo's at right now. They want to allow the users to control the warp and weft and tiling and blocking factors, which turn into fixed unroll and fixed inlining decisions so that they can be guaranteed of a certain shape of code that hits the GPU, which I get. In
hmm.
a couple of years, I think that'll be all stale. It's fine right
they
now as a strategy,
hmm.
but they've complicated their build process enormously, enormously to make this work. And I don't understand how they've gone down the path they've gone of implementation, but totally makes sense if the compiler's not smart enough to right now make intelligent decisions about how to mutate a model to fit on a different GPU and the user can do it better. Okay, fine. Put some annotations
I
in
think there
inline,
is
register,
yeah, yeah, I
frequency
think
block.
there is
These are all annotations that you want
a
to totally honor at some point in time and not later.
yeah.
Fine. All right. Wow. We've gone all kind of craziness here. I didn't realize how long it was. Um,
Make a special version of the annotation that says always inline if it's before this date. Set it 2 years in the future, so it automatically means nothing on that date.
what really happens is the compiler writers start ignoring it, and then the users bitch, and then there's a lot of back and forth where you see places where you're just better by ignoring. Then there's a flag that says just ignore it because it sucks. And then one user has this special case of the ancient hardware where it's always better for him to do it the way he says. And everyone else just moves on. And then there's the general, theme of don't use the fucking inline keyword. Don't be a knucklehead. And and then people quit using it, and then I don't know, life goes on, and the one guy in the back, and you have some flag somewhere where you say, "I'm ignoring this if rare ever only set by Joe Blow, blah blah blah." Fine. Oh, XKCD. Uh-oh. Shows up in chat. Should I bring it up here? Broke my workflow. Yes. Okay. Where do I find the share here? Exactly what I'm talking about.
You need the inline keyword to have a parameter, which is like you have to set this to 1 in order to work. And then next year, you have to set it to 2. So if you want it to use it, you have to continually update it. Otherwise, it's going to go away.
Yeah. Emacs. You notice this XKCD uses the word Emacs. Fine. All right. Now I can find the stop it here. Yes.
So where simple is going with all the flux?
I don't know. There are Emacs users at this company, so I'm no longer the sole Emacs user on the planet. It's very nice. That piece is nice.
I mean, where's simple is going?
Oh, where's
Vector
simple going?
blocking.
I'm sorry.
Yeah.
It's slowed way down while I get sorted on what I'm doing with Modular. Tommy, who never gets on these talks, but he's been plunking away at all kinds of random things, is trying
Mm.
to get and or put in, and I'm trying to talk him into doing the optimistic optimization pass as a tutorial thing. Derek did some work on some readmes. I kind of thinking it'll be my fun background project for a little while. And I'm also looking to see if there's some way I can drag this tech into Modular, um, because it does a lot of things that Modular needs done, and it does them much smaller code base and much quicker. Now, it doesn't do
I assumed you were going to
everything.
pull more AA logic in and simple logic.
There's a typing thing goes on in Modular for which I may pull in some of the AA typing things. So that's all open questions.
Related to the README looks that I did, and I kind of got distracted because I've been uh, focused on a couple other things, but I still want to get through them. The thinking that I had on them was the later ones are very much like going into details on like how like how
Yeah,
instruction encoding works and stuff like that
yeah,
versus there isn't really much narrative in terms of like what are the design decisions here, and I thought that the readmes were mostly off track, but then that's why I hadn't posted much about it, because I was like, I got to go back to the earlier ones and make sure I'm not mistaken, because I thought that they were more about the design and less about the nitty gritty.
right. So it goes back and forth, but I think it should be more about the design, just the nitty gritty. So Dib did a bunch of early readmes. For him, it was all brand fucking new, everything in the compiler. So he got nitty gritty at a bunch of times that, I don't know, makes a lot of sense. But he always kept a high level, big picture view. That high level big picture view started to run into trouble when I went back and would like to redo some of the implementations because, your first cut didn't get things right. So I redid some. I
Yes.
did go back and redo the prior readmes and the like. Um, and then like register allocator is big and complicated. So it only got a really high level overview. And a lot of the allocation strategies or spilling strategies mutated a bunch of times over time. You and I worked on that funny chip.
Yeah.
I mutated the spilling strategies quite a bit,
Yeah.
and they're tied in with like the local scheduler and stuff. And so
Right.
that's a design decision how they're tied in. That's not obvious. It's not in the README.
Yeah. Yeah. By the way, anything that's like a hook for the untether compiler can just be stripped out now.
Yeah, it's most. I wanted to make sure that it was clear. It was clear of any untether accidental tech. I think there may be a comment about M2 living on,
Yeah. Yeah, there were a
but
couple of places where I had to like have like a uh
oh, right,
like a dummy function that you
right.
called because I overrode it or
Because you
something.
overrode it. That does change the instruction selection path to make it more complicated. And I'm going back and forth because it kind of allows somebody who is not wanting to put their port of simple in the public domain to have a hook where they can say, and here I'm going off to my own implementation of things. So we could argue that that's not going to happen. Like the path you took.
I would argue that the person who does that's gonna just have to come forward and be like, "Hey, can I hook in here or there?" and sort of talk it through with you. And probably people aren't going to need the exact hook that we needed because they have some
So
other weird problem
your,
not
your
related to the
thesis
weird
is
one we had.
ditch all the hooks, simplify
Yeah,
life, and if somebody wants something, we'll make one. Like the obvious hack
you
here
can
is
even
using
put it
modular.
if you want, just put it in the README and say like, "Hey, we're
For
open
sure.
to this," but it would be a discussion
Yeah. So the
rather than just
main
have random hooks nobody's
hook
using.
that I got, the biggest single hook that was an issue was you had a node description that did not inherit from the simple node file, which meant that they didn't share a class hierarchy, which meant I couldn't cast one to another, which meant I had to have a walk of Derek's nodes produce an output of simple nodes. And
Yeah,
that
but that was in my project. That
it
wasn't in
was
simple.
the hook for that remains in simple to this day.
Okay, yeah, the hook.
And it's obnoxiously it's obnoxious, and that would be the one place where I'd be happy to yank and simplify.
Yeah, well, feel free.
Yeah, okay. Yeah, I mean I knew Untether disappeared. That's fine. It's
Yeah,
sad. I kind
it
of
is sad. And
pain.
I pushed to get the compiler open sourced, but
Yeah.
if it happens, it's going to be like in a year.
Yeah, right. Yeah, yeah. If it happens, there'll be no one cares who took it. It's another.
Yeah. I was just, I thought, well, it'd be a nice thing to show, if I ever decide to go out and get a compiler job, like, hey, I built this
Yeah.
giant thing and it works.
The community of GOG, the great old games
Yeah, I
website.
don't think that IP is the crown jewels.
No, they did some cool stuff. And I've talked to people at Modular about a bunch of other startups who are looking at doing AI chips. And the things that Untether were doing are not, there's a bunch of people think that's the right thing. There's a path forward there. I think Derek and I worked our way through half of that problem, and Dash was working through another chunk of it. And there is a reasonable answer there, and Modular might end up wanting to go down that path. They're better set to solve this problem than Untether is
So you're
for
gonna
the
have
Untethered
modular
challenge.
running
Yeah,
on Derek's chip by the
for
end of the
sure.
week.
I'm sorry, what, Aaron?
You're gonna have all the modular code running on Derek's chip by the end of the week.
Well, I don't have a copy of
Uh,
Derek's chip, so
a week seems long. I'd probably 3 or 4 days.
3 days.
3 days.
3 days.
It's official.
Leave on. Where's leave on? 3 days.
Yeah.
Fine. All right. Well, I can
I
call
mean,
it.
there are some crazy stories
Well,
of people porting the JVM in a week or two to new chips.
When I was doing regular ports to JVM, yes, it was not the end of the world. It didn't take that long.
One question is, are you thinking of doing some you have done in simple on top of MLIR infrastructure, or are you thinking of doing it entirely from the scratch?
Um, I think Simple's portable enough that I wouldn't necessarily trash it. Now, where the right hooks are. So here is a hypothetical that would raise a whole lot of eyebrows at Modular. So I'm saying it publicly, and I'm sure it'll come back to me, but I don't care. This is a thing that has to be looked at. A new front end that does Mojo with CliffClick's typing strategy, which is substantially different, but I'm damn sure I can type whatever I think Mojo's doing. It's just not that much. Goes through the standard CF nodes IR, but the backend, the x86 backend, we can argue left or right on, but the GPU backend wants to go to where the GPU manufacturers know how to port their hardware to, which possibly turns into MLIR and some sort of LLVM backend piece, but yanks them from the front end forward. Okay, so having said that, almost surely it's not going to be written in Java. So then it's a rewrite of simple in C++. Okay, well, I've done that before at C2. Yeah, simplified life, and I've cleaned up and fixed my mistakes. Okay, yada yada. 25 years later, yet another version of C2 written in C++. Fine. There's a wish from Chris Latner that I would write it in Mojo, but for that to happen, Mojo itself has to be a stable
So
user development experience.
uh,
And it's not
Mojo,
currently a stable user development experience.
Write
they
it
would
in
like
AA.
that. They have
Okay, a bunch of people
self-hosting
want to say
Mojo.
something. Let's go Aaron first, and then I'll go to Theodore in a second.
I said you should write your new compiler in AA.
That's also backed by Java underneath, which won't actually. That's it.
My comment is about Mojo, self-hosting Mojo. It
Yeah,
will be,
yeah.
it will, they
The
would
goal would
like
be
that idea.
self-hosting, absolutely.
And that they would like that idea. Why not?
And that's because of Chris's background, but mine as well. On
But
the other
that means
hand, the company and the people who piled money into Modular want Modular to
that
sell the ability to do, large language models on GPUs, for which self-hosting Mojo is not
hmm,
not a high priority.
but that means that if they want that road, the intermediate, what you will write it in the first version doesn't matter. It can be Java, it can be anything that produce code.
Having said that, I don't think anyone at Modular was going to pick up Java as an implementation strategy.
Okay.
On the other hand, it's clearly fast, it's efficient, it's an amazingly robust tool chain.
Hmm.
It completely would work as as a development
Hmm.
for what they're doing. And no one there is going to want to deal with that or think about it or believe it. So I don't think
But
that's going to sell.
they'll say, yeah, C++. No Java.
Yeah, if instead I had a working self-hosted Mojo, then a bunch of people would drop on the pile on that one. So Mojo as a way to write the large language models It makes sense because of how it's just being targeted that way. So it totally makes
Uh,
sense.
hold up. Are Mojo always targeting GPU? Is in general
No,
practice?
it can
So,
target x86, it can target GPU.
so there is some consensus what could be supported by the GPU and what should boil
And
down
there's
to the
a
CPU.
flag that you set says this code goes GPU and this code does not.
Hmm.
And, on a lexical scope basis. So you can
Hmm.
push code left and right. So the generator is not making the decision, the user is. That's fine. What I was trying to get to was that the things that drive GPUs efficiently in bulk have complicated launch and retry and pullback and too overloaded and not enough. And they're already getting driven by code generated by Mojo. So the guys who want to drive it at that level want a Mojo that has strong concurrent algorithm support and strong, multi-threaded and strong I/O support things, so, networking stacks and HTML and yada yada, for which is a general purpose language, for which it totally makes sense to write a compiler in a general purpose language.
Hmm.
So there's some drawl that says Mojo goes into a real general purpose systems language because it wants to get pulled in closer to the management of the GPUs at a large scale, not just throwing kernels on the GPU.
That would be that would mean that it's much more heavily geared for the GPUs instead of CPUs instead of.
They have an interesting line they've drawn. I don't. It's like Python with strong types.
Mm-hmm.
Can I write a compiler in Python with strong types? Yeah, sure.
But
Now,
not as nearly all the code that looks like Python can be compiled for the GPU. Only processing some iterations, something like that that can fit the GPU or the
they
GPU design.
have in the typing system support for user-defined complicated ways of defining tiling and blocking for the
Mm.
GPUs. So they
And
have in the
and they would
language syntax and the language typing.
only for GPUs, or if the GPU is not present, the tiling will convert to the CPU back to the
Yeah,
CPU
right.
sequential.
Somebody
Okay.
wants to say, yeah, I'm going to target x86 instead, then you change. You run your algorithm. It's like not derived types. It's
Mm.
futark types,
Mm.
not dependent types totally.
Mm. Yeah,
But they
I
have
got
a
the
typing
sense.
algebra that lets them push
Yeah,
through complicated setups and how you're going to do.
I got a sense that where that might how that might look. Yeah.
Yeah,
I
okay.
mean, it's been a dream for a while to have multiple architectures on the same CPU and let the runtime decide where to stick code.
Yeah.
Yeah,
It's pretty easy these days to build a CPU that has a handful of efficiency cores that use very little power and a handful of
high power cores.
power cores that use a lot more electricity but have a lot more straight line execution.
Right.
And then the GPU, and you kind of just want to write your code and let the runtime decide.
Yeah.
Oh, you've
I
got a
think
bunch of management code stuff that
yeah,
barely needs computation and is just doing a bunch of logistics. Great, stick it on an efficiency core where it's not going to burn much power. Okay.
yeah, I
Here's a
think
thing that's super complicated, put it on a performance core. Here's a thing that fans out super well, stick it on a GPU.
I think that's where we'll head in the long run. And I think Modular could do it. They have the GPU thing pretty well figured out. So I think they should charge ahead because that's where the market is, and there's giant wads of money, and they need to get the money fast. But that would turn into giant market share, would turn into giant money, and blah blah blah. There's a self-feeding frenzy that goes on if they can push it. So there's no slowing down their momentum. That would be bad. Um, that being said, when the lack of the ability to move Mojo forward and do development as a user experience in Mojo because you can't get the debugger squared away or whatever the hell becomes the bottleneck, there is a decision point to be made about rejiggering how Mojo itself internally runs. So I am going to set myself up so that if it makes sense, I'll push them into sea of nodes.
Well, that's why I started with the JIT comparison thing. What I would want from Mojo is that it's doing all this fancy ahead of time compile stuff to
Mhm.
get performance, but that I can also connect to my running Mojo process and it'll just give me a Python REPL and I can examine what's going on in the
Yeah,
heap because
yeah,
you gave me a Python REPL that has access to the globals.
yeah. That's the goal. Having said that, that's the goal. The reality is not quite there.
And again, you're probably not going to trip over some of the really bad, it's hard to JIT Python problems because you can make changes to
Yeah,
the
that they have, yes. Step one was to say we are going to be ahead of time compiled and therefore and strongly typed, and therefore those things that were not Python in that way. We
Well,
do
that's why
not have to
you
be
mentioned that you
100%.
might get sort of click types in there that are your combination of Henry-Milner and forward flow typing.
They should disappear under the things. Like you shouldn't be able to see them typically unless
Right.
you want to, unless Chris, who's very, very fond of Mojo, decides he wants to expand the typing system and allow more interesting types, and I can provide performance for them as well. Yeah, it might expand. And you become more like a Scala thing. It has some crazy ability, but good performance.
Right, but what I'm
Oscar.
saying is a lot of what people want who are Python programmers today is to not type the types.
Yes.
They want to change the type of a thing in one place and have it just flow through all of the code.
Yeah, I have this
So
fantasy that
click
says I'll
types
write
seem
a
like a good
Mojo
fit.
parser and just say, just don't bother to write the types.
Yeah.
Right. It's
Uh,
I
strongly
got your
typed
back.
because it's click types, but you also don't type the types because they end up propagating out of the libraries that you
but
used. You used a bunch of
other
libraries that were super strongly typed because they're compiling the GPU stuff, and those
other
types will
other
just bleed all over the place.
Mm. How can you signify the tiling if you cannot fold it into a type? So you have to signify that would be intended for the GPU. So there is a pretty delicate line here. So on the one hand, you don't like types like Hindlay-Milner doesn't designate anywhere, but at some point you need that types at least to tell you something, to guarantee you something. So the chosen type doesn't change constantly. On the other side, when you're forced to like Scala to write the types at least on the function level, if they become more complicated, they become unwieldy to write, and that is the high end spectrum of the hardness. If there's some path in the middle that you still want some of the typing to designate some of the information where you want to guarantee that, then there is a good trade-off there.
And there's an interesting talking about spectrum. It's funny because in dependently typed languages community, the trend I am seeing evolving is that people see that writing types is the first thing, and the types are precise enough that the program source code falls out as a
Yeah,
pretty obvious choice for the solver. I mean,
the
there's only
easy.
you have precise enough type, there's only one program you can express.
Uh,
So it's trivial, and you don't even have to write this down because why would you? It's
it,
just
it
like programmer annotation for the type, but the
it
type
re-
is the specification. I think that's interesting if we are going to see more coding with LLMs, because
mm.
maybe writing those higher level specifications, maybe that's all that matters, and they better be precise enough so the
on
LLMs
that
cannot mess it up.
on that matter, if you write the types for certainly, then these guarantees can change underneath you. So you can guarantee by the type, but the implementation underneath it can change it if as long as it still guarantees that
Exactly.
what the type provides. So that would be a good abstraction. Yes, I'm agreeing with you. Yes.
Even for things, it's like we were talking in the previous compiler coffee clubs about optimizing collections, like data structures,
Yeah.
like databases do know where to use merge, join, where to use nested
Mm.
loop, where to use hash. Well, if you just specify a high enough interface for your collection that you can get some things, you can set some things, you can have some association between key and value, maybe that's all you need. And it's the
Mm.
runtime's job to choose the data structure for you. And then again, it may be just enough to capture this in the type. And the
Yeah.
implementation of the data structure, that's the job of the compiler to synthesize it.
Yeah. So there is a if there is a middle path that you can work there, omit the types, or if you want guarantees, put the types, then that would be a good trade-off.
All right. I'm gonna wind it down here.
Yeah. Yeah. Yeah.
Anyone else?
So henceforth, should we just refer to them as click types to save from saying combination forward flow Henry-Milner?
I would love to have a little more hard theory proof written somewhere. I guess you could go that way. We can say click
You're
types.
not quite ready to write the paper click
I'm,
types?
I'm not quite ready to write the paper. But for me, writing papers really have an implementation that runs, and I have a weak implementation that runs a few things, and it's not robust enough for me to say, okay, I got all the corners covered.
Fair enough.
All right.
Do people wait until they've got everything figured out before they write papers? I thought you
No, it's
just
just me.
scramble out a paper as quickly as you can, as soon as you have
No,
an idea.
no. If you're
Depends if
in
you're
that
If
trying
you're
to get tenure.
academic, if you're
and
academic,
yeah, write or die, you write, and then it's a lot of crap gets flooded through. And I'm always of
Right.
the first it works, it's being used by 100 million people worldwide, and it's really solid. Oh, maybe it's good enough to write about now. Not necessarily a sane bar.
Well, you'll be sure to have a correct paper then.
You'd like to believe so, yeah.
Yeah.
This
We
one I'm
should
a
lower the
little
bar
less.
from 100 million people using click types to $100 million worth of hardware using click types.
Oh, there you go.
Yeah, that's like,
It's that I don't have a like implementations of VMs and shit like that. I know what I know, and I'm good. Here in the typing realm, I'm doing things that look completely obvious and should be, but why is no one else doing this? And I'm wondering, what did I miss?
well,
So
if
maybe
you
I do
wrote the
have it right.
paper, I mean, isn't that why you write the paper and then you get a bunch of really smart people who
Who tell you that
are
you're the
trying
dumbass in
to like
public?
think of every possible way that they can show that you're wrong?
Yeah,
Because
yeah.
that's,
There's an XKCD for that one too. No, it's not XKCD. It's this other guy.
but the thing is that, all that people showing you're wrong, then it's like, okay, now fix it and I write another paper.
And there's another paper after that. Yeah.
But it helps
There's
if you
a
can
really
download a
nice
REPL before
other
making that
comic
argument.
who's Zach Wiener. He does one where he says, first some guy has an intuition, wow, can this be really true? Oh my God, it changes things. And then the next page is like all these mathematicians from the 1900s are saying, no, this guy's completely dumb. Well, maybe we can rewrite all of mathematics to prove he's wrong, and we'll kill him. And then, there's the changing of the guard and the old mathematician's on his deathbed saying, I spit at thee. And the next one is the young prof at a university teaching kids. We just talked about this yesterday. How do you not get it? So I'm somewhere worried about getting the old guard to come chew on my ass, telling me, you're dumbass. But maybe I shouldn't be. I should just go,
Well,
guys, you can do
if
this thing.
if you have it all completely worked out and they can't find anything to argue about, they'll kill you even worse by ignoring you.
That's the other option. Yeah, absolutely. Yeah, yeah.
And then there'll be no excuse to
No,
write the
no, no,
follow-up
no,
paper
no,
because the
no,
first one was
no, I'm not
perfect.
looking. No.
Yeah, buried in obscurity, where it
No, there you go.
belongs. God damn it!
All right, all right. Enough ranting about the state of the academic
But
universe.
but there's one thing that I wanted to ask. Maybe it's too big a topic, so it could be for another
You could
time. But
ask it an
like,
hour ago. Go now, do it.
well, it's a topic I've been thinking about for a long time, and I guess I've asked a few times. But like now you're seeing MLIR a bit more, and I still have this idea that MLIR and C of nodes fit very nicely together, and like. I kind of wonder if that's something, a direction that Simple could take, or somebody's
Right.
thinking about this.
It is an easy answer, and I know jack all about MLIR yet.
Right. Okay.
I will. It's somewhere 6 months from now. I probably will be a fucking expert, undesired fucking expert on MLIR, but not now. So you
Okay.
probably will get an answer to that.
All right. I'm looking forward to that because,
Okay, sounds good.
yeah,
All right,
save me
next week,
the effort.
and you can pick on my MLR knowledge next week and measure it week by week and see when I cross the threshold. I know what I'm doing, but it's not yet. All right.
Bye.
Bye.